Alright guys, hi everyone. Today I'm going to be explaining about the functions. This is a project video sent to the math class, the mathematics. This is done by me. Excuse me for not introducing myself. I'm Salahuddin Yama from grade 10B. So let's let's not waste any time and let's get started. So alright guys, let's get to the first topic. And so this is the definition of the functions. But before I'm going to start this, I would like to inform you something that I'm not a very I'm not a kind of person that is very good in math, so I'll try my best to explain everything as understandable as possible because I'm not that professional in math. I'm more like a business kind of guy, not really math. So please bear with me, and I'm going to try to make it the most understandable for you. Okay, so let's get started. I shouldn't write with this with this yellow color. I don't know if you could see this or not, but I'm going to explain it to you real quick. Specific kind of relation in which each domain is paired with only one range element is a function. Alright, so there's more to it. In a relation, x value can't be repeated. X value can't be repeated, and each x value has to have only one pair. Each function is a relation, but each relation is not a function. And then the last one but not least is that y values can be repeated. And I'm gonna give you more examples in the next paper real quick. Alright guys, now we came to an example part. So as you remember just now, we just talked about the definition of the functions that and about the relation and stuff, and we just explained that the x value can't be repeated. Alright, x value can be repeated, and as you see, here's the x value, which has 1 1 1. So what does this indicate? So this means that this is not a function, right? Because all the x are repeated. This is not a function. But in the second example here, the y values are all the same. So is it a function? Yes, it could be, because just now it says y values can be repeated, but the x value can't. So remember this, don't get it wrong guys. So the y value can be repeated. So this is a function. Alright, we're done with this example part. Now let's move on. Okay, alright guys, now we can go more to the more example, and let's do it with the first one. So as you can see, we got all of these numbers in order, and so how can we know is this is a function? So let's check the x value: 5, -2, -8, and -6 and 7. So is this the same? No, of course, right? So this is totally a function. Since we check our x value, all of them are not the same. And it shouldn't be right, because the rule says that x value can't be repeated, so that's why this is a function. Okay, let's see. 5, -2, 8, 6, and 7. Bam! There you go. This is not This is totally a function. Okay, so let's move on. The second example. Is this a function? Let's see. So uh, we got negative 6 right here, 7, 7, and 8. I'm just saying the x value only, right? I'm not saying the y value. So we got negative 6 here, negative 7, negative 7. Oh my god, we got a problem. So that is not a function. And we got one more 8. But still, two of these x value are the same. So since we have got two x value which is the same, this is not a function. In the rules, guys, in the rules they said that x value can't be repeated. Alright guys, let's move on. Alright, let's move on. The domain set of the component of a relation. When a relation is shown on a graph, set of all x values. Range set of a second component of a relation, and when relation is shown on a graph, set of all y values. Okay, now let's move on to the next paper. Alright, now I'm going to explain about more on the domain set and is it function or not. Okay, so any domain element cannot be left, and in range set some elements and domain elements can pair with only one range element. For example, let's see, we can see that 3 pairs 4, 1 and 2 pairs with the range set. So this is for function. Alright, now this one, don't focus on the blue line, focus on only the red line. All of this should be function, but there's one missing, which is 2. Alright, 1 and 9 they got pairs already, but only 2 are left, they got no pairs, so it is not a function. Having a function is like having these all numbers connected and not any one left. So as you can read here, any domain set cannot be left, so you can't just put here, you can just do like this, you can't just left one or two number left without a line having the pair with one another. Okay, so let's move on to the next example. 6, 1, 9, 4, 3, 2. 6 pair with 3, 1 and 9 pair with 2. So it is a function. It pairs with something. Alright, so you gotta remember that it cannot be left. Alright, okay, let's move on. Alright, the next one is the explanation of all the function. I mean, for the function, there's an input, then is an output. There's an independent variable and there's an dependent variable. There's a domain element and there's the range element. There's x changed to f parenthesis x. Alright guys, now let's move on to the vertical line test. So if we draw all the possible vertical lines on the graph of the relation, it is a function if the lines cuts the graph no more than once. Alright, so and it is not a function if at least one line cuts more than once. And sorry if my camera was a little bit shaky because I was holding with my hand. Right now I got no tripod right now, so I would like to apologize for that. Now let's get continue. Okay, so how can we prove this? So this is an example right here, and how can it be a function? So as you can see, the line is going this way, is going up, and we can put any line down here without cutting line more than once, right? Because it got only one line, so it can prove that this is a function right here. We can just cross, bam, 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 right there. It's still a function. Now, how about this one? What do you think? And this one, how is it not a function, right? Well, this is the line, and then so what if I cross it just right here? Bam! I got one line that cuts more than once, so it is totally not a function right here. Even though I do this, like this, like this, like this is not a function because anyway my line cuts more than once already, so it is not a function, guys. So be careful right here too. Alright, now let's get on to the next one. Alright guys, now we move on to the function composition. So first we got to find f of x, then we're going to find the g. Alright, so um, by doing this, I'm going to show you how to do it. Alright, let's get started then. First you want to swap, put in this input, put x as a 2, so f2 equals to, now you can see this x, right? We put in 2 instead, and so 2, we got x right here, we put parentheses 2 and minus 3. Then after that we times this together, we got 4 minus 3, and the answer is that we got f2 equals to 1. That's the answer right there. Alright, so let's move on to the next step. And so as we know x, we got the 5x plus 1, and here we're gonna find out about this problem. So first we put 2, see x is 5x plus 1, so we gotta put in 5x plus 1, and don't forget this part. Alright, 3 minus 3. So when we take 5 times 2 and plus this together, we'll get 10x plus 2 and minus 3. So the answer, it is going to be the f g x equals to 10x minus 1. Bam, there you go, right there. There's the answer. Alright, now after we finish the function composition, let's move on to the next one. Alright, so now we're doing the inverse function. An inverse function is a function that reverses another function. That is, if x is a function mapping x to y, then the inverse function of f maps y back to c. So basically inverse is doing the reverse thing, the opposite of it. So some function have inverse function which undoes what it does. So if a function is f parenthesis x has an inverse, number one, f minus 1 x stands for inverse function, and it is a function as well. So basically f negative power negative 1 x is a notation for an inverse function. Okay, so if you are going to write inverse function algebraically, in order to find the inverse of a function, we should uh, be following these steps, which is first uh, we should replace the f of x with y, then swap x and y, and solve for y. Then the last is to replace y with f power negative 1 x. Okay, so first let's solve this one. So f, I'm going to put x as 2, so 2 times 2, because it's x already, so we times 2, sorry I put that instead, and plus 4, we got 8. Now what if I do it in 3? So f3, 2 times 3 plus 4, we get 10, right? This is just like kind of like introduction, first step, and I'll show you more example in the next part. Okay, so let's solve another question. So we put y 7x plus 3, and as you can see that you put x minus 3 over 7 equals to 7y. 7, we cut off this, and next part, f2x equals to, wait, I got to do this. So fy equal to minus 7 plus 3, then x should be equal to y. It's 3, okay. So f2x, so it should be x minus 3 over 7. So we got it. Alright, let's move on to the next page. Alright guys, so hope you enjoy and learn more from the video, and thank you everyone, including Mr. Mustafa, for watching this video. I know it may not be a very good explanation, but I try my best. Yes, so thank you everyone, and hope you study hard in math and try to achieve the best score as you can, and wish you all the best luck, and that's it. Okay guys, hope you enjoyed this video. Thanks a lot for watching. See you next time. Peace.